Okay. Similarities between capital budgeting and asset valuation. We're pretty much looking at the same process. We look at the cash flows. And we compare the present value of those cash flows to the cost of the asset or the project. We estimate those cash flows when we're in for capital budgeting project. We evaluate the riskiness of those cash flows. That determines our required rate of return. Many times when we're dealing with a capital budgeting project, the minimum we would want to accept would be the firm's cost of capital. Accepting anything less than any rate below the firm's cost of capital is going to result in a reduction in value of the firm. So that's an important concept to understand. We'll compute the present value of those cash flows. Then we get an idea of the value of that asset to the firm or the project, depending on what we compare that PV. Compare the PV of those cash flows with the initial investment, and then we purchase it if the present value of the cash flow is greater than the investment. If the present value is greater, that means that we're earning a return in excess of our required rate of return. Now, NPV, if you were going to do it by hand, looks like this. The NPV is equal to the initial cash flow. So this would be a negative. We're buying the asset. We're investing in the project. So that's a negative. And then we take the present value of all the future cash flows. So we've got the projected first cash flow. We divide that by 1 plus our required rate of return. It's the first power because it's in the first year. Second cash flow is 1 plus the required rate of return squared, and so on throughout the entire life of the project. We have a couple of example projects here. We have net cash flows for project S and L. So with other 4-year projects, the initial costs of both are $3,000. But you can see that project S had the cash flow is front end loaded, as opposed to project L. The cash flows are back end loaded. So this is going to be this is going to impact our decision, because in our required rate of return will impact our decision as well, because if we have a high required rate of return, it's going to push us towards the front end loaded. If we have a low required rate of return, it's going to place more emphasis on the longer return period. So next slide has the timelines for both of those both the projects, S and L. So project S, $3,000 initial cost and $1,500 in the first year in net cash flow. $1,200 in the second, $800 in the third, $300 in the fourth. So, and then L, as we mentioned, it's back end loaded. The initial cost is still $3,000, with $400 in the first year, $900 in the second year, $1,300 in the third year, and $1,500 in the fourth year. So the NPV for Project S looks like this, where the $1,500, this is at 10%, would be divided by 1.1, and that goes at $1,363.64. The $1,200 here in year 2 would be divided by 1.1, 1 plus the rate, that would be squared. The $800 would be divided by 1.1 cubed, and the $300 would be divided by 1.1 to the 4th power. So the net present value, so we sum up all the present values and then add back that initial cost, and we get an NPV of $161.33. I'm going to show you how to do it on your calculator. So the cash flow function is CF. So to access it, you go second CF, and you always want to clear it out. So the CF0 is the $3,000, so it'd be 3,000. Hit the plus minus to make it a negative, hit enter, and then we go down. So C01 is the $1,500. Enter. And then right here, F01 is frequency. Default is 1. These cash flows only occur one time, so we don't have to worry about F0, 1, 2, 3, or 4. They're going to be already. So C02 is 1,200. Enter. And I'm going to slide this over so we can see the cash flows. So then we go down to C03. That's going to be 800. And then C04 is going to be 300. Enter. So I hit the NPV key, and I is our 10%. Enter. And then we go down arrow and hit compute, and we get $161.33. So we go to the next slide. It shows the calculation basically done by hand. So project S again. All right. So the $3,000 initial cost, the $1,500 in the first year divided by 1.1 to the 1st power, which is 1.1. Then the 1,200, the second year cash flow divided by 1.1 squared. 800 divided by 1.1 cubed, 300 divided by 1.1 to the 4th power. We do the calculations and add everything up, and we get the NPV of $161.33. So the next slide shows how to enter it into the calculator. Doesn't show all the keystrokes. We're going to go back and we're going to do the same process for project L. So the project L cash flows, and I'll bring up the calculator. So clear. All right. Second cash flow, second clear. We could leave the $3,000 in there, but it's best just to clear it out every time. So that's CF0 is 3,000, a negative, and then C01 400. Enter, and down arrow twice, and it's 9. Cash flow 2 or C02 is 900. Then go down twice. Then C03 is 1,300. Whoops, I can clear it out since I made a mistake. 1,300, enter, and then down arrow twice. C04 is 1,500. Enter. NPV, and I is 10%. Enter, and then down. And then we compute. Go 108.67. One other thing about the cash flow function, to go back to it, we go second cash flow. The registers, as you scroll through them, they go in a circle. So if I scroll down, I get 400, 900, 1300, 1500. And then once I go past the F05, it goes back to the beginning. If I entered something in F05, I would be able to enter if I entered a cash flow in register 5 or C05, I'd be able to enter a cash flow for 6. As I mentioned previously, the examples for are some of the examples are done in Excel as well. You can use Excel if you choose to. So we will start lecture 3 here. Let's go. So the rationale for the NPV method.